Hi, geometry students. So go ahead and check your answers to the day 4 homework. Feel free to pause the video if you need more time. And today you are going to be taking a short quiz on days 1 through 3. But before we do that, we are going to do a short lesson on lateral and surface area of prisms and cylinders. So take out your notes. Feel free to pause if you need a moment. All right, a polyhedron is a three-dimensional figure whose surfaces are polygons. A face is a flat surface of a polyhedron in the shape of a polygon. So looking down below here, this rectangular prism I have here is a polyhedron. And the first two arrows, so below here, I'm pointing to this right here, this is describing two different faces. So you have those rectangles that are making up the polyhedron. An edge is a segment that is formed by the intersection of two faces. So you can see those two faces, this one and this one, come together. So here's an edge. And then if you look here, this is pointing to an edge right there. And then lastly, a vertex is a point where three or more edges intersect. So you can see this edge, and this edge are all meeting right here. So that makes that a vertex. A prism is a polyhedron with exactly two congruent parallel faces called the bases. And the prism is always named by the shape of its bases. The other faces are called lateral faces. So a lot of words here. So if we look at this one right here, we can see the two parallel congruent bases. And because they are pentagons, this is called a pentagonal prism. So if those are the bases, all the other sides, the faces that you see, are the lateral faces. The next one is called a triangular prism because you can see the congruent bases that are parallel, and then you have your lateral faces on the side. This last one here on the far right, you actually have an option which are the bases. A lot of times we like to think about the bases being the top and the bottom, but it doesn't have to be. So if we say these are the two rectangular bases, this would be a rectangular prism. And then we just drew in here the height, which is, remember, always perpendicular with one of the bases. Another word for height is the altitude. So an altitude of a prism is a perpendicular segment that joins the planes of the bases. The height h of the prism is the length of the altitude. So this right here is your altitude, and its length is going to be our height. So lateral area of a prism is just the sum of all the areas of the lateral faces. In other words, you're not going to include any of the bases. So if I take this triangular prism and I open it up, I'm just going to find the area of these lateral faces, and I'm not going to include the bases. Surface area is when I take all those lateral areas I was just talking about, but I also include the bases. So lateral area, don't include the bases. Surface area, you're going to include everything. So if I'm asking you to find the lateral area and surface area of this triangular prism, I want you to think about a few things. Why is this a triangular prism? You should be thinking because I can see these parallel congruent bases. So that's why it's a triangular prism. So for my lateral area, I just want to add up all of the sides, all the surfaces that are not part of the bases. So I've got the one facing me, I've got the one on the bottom, and I've got the one on the back side. So I've got those three surfaces, and they're all rectangles. So the bottom rectangle is 4 by 8. The rectangle that's facing me popping out, I know it's 8 by something. I've got to figure out this distance. Well, I have a right triangle here. So a squared plus b squared equals c squared. So leg squared plus the other leg squared equals c squared. So 16 plus 16 equals c squared. 32 is c squared. So now I have to take the square root. So c is radical 32. I'm going to do menu number factor on my calculator. And that tells me that I have 2 squared times 2 squared times 2. So out comes the 2, out comes the 2. So c is 4 radical 2. So 4 radical 2. And then I also have the back side, and that is a dimension of 8 by 4 again. So we have 32 plus 32 radical 2 plus 32. So that's going to give me 64 plus 32 radical 2. So that's my lateral area, and that would be in inches squared. For my surface area, I still have the lateral area, but now I have to add on the area of my bases. So the area of my bases are going to be here and here. So see how I have 2 triangles? So I'm just going to have to add in 2 triangles. So 2 times base times height divided by 2. So the base and the height are 4 and 4. So 2 times 4 times 4 divided by 2. So 16 is what I need to add on. So my surface area, I'm going to add the 64 and the 16 together. So that's going to give me 80 plus 32 radical 2 inches squared. All right, we also are going to talk about the formula for lateral area and surface area of a right circular cylinder. So you can see that right here in this example. There it is. All right, so the lateral area. All right, let's take a look at something. So here is a right circular cylinder. And the lateral area, remember, is the area of the surfaces not including the base. So think about this as a can, and I've got to take the can tops off. So I am going to slowly open my can on both sides. And then I'm going to cut my can in half, and I'm going to peel it apart. So the top 2 surfaces, those top circles, are not going to be a part of my lateral area. So if I keep sliding, do you see where the length of my rectangle is coming from? It's coming from the circumference of that circle. So the lateral area is simply the circumference of the circle, because that's going to be my length, times the height of my cylinder. So going back to this, lateral area is 2 pi RH. This is simply the circumference of my circle times h. The surface area is going to be the same thing. This is the lateral area. But then I have to add on the 2 circles. So once again, just this part here, I don't know if you can see that my screen, I'm putting little dots all over the big white rectangle. That is my lateral area, but my surface area is going to add in the 2 circles as well. All right, so let's try an example here. So we're going to find the lateral area and surface area for this cylinder. All right, so my lateral area, I'm going to think about taking the top off and opening this up. So I have a height of 11, and then this comes from me opening up the circle and finding the circumference of the circle. So that's why it's 2 pi r times the height. So 2 pi. The radius is half the diameter, so that's why it's 3.5. And then the height is 11. It does say find the exact, so I'm going to type in the 2 and the 3.5 and the 11 in my calculator to get 77, and then it's pi inches squared. For my surface area, I'm going to start with the lateral area, but now I need to add the 2 circles. So 2 pi r squared. So 2 pi, and my radius, remember, is 3.5. So in my calculator, I'm going to do 3.5 squared, and then I'm going to multiply by 2. So that's 24.5 pi plus the 77 pi. So altogether, that's 101.5 pi inches squared. And that's for my surface area. Okay, lastly, find the lateral area to the nearest integer. Well, lateral area, remember, I'm not going to include my bases. I've got to do all the way around, but I'm not going to do this base or this base. And I know they're bases because they're parallel and congruent to each other. So this octagon, this regular octagon, you can see I have 8 rectangles. So 8 times base times height. So 8 times the base of the rectangle is 22. And then the height you can see is 5. So I multiply those together, and my lateral area is 880 centimeters squared. So your homework tonight is on this. So when you finish the quiz, you may work on this homework. Reminder, formulas to know for the quiz. You need to know this formula for area of a kite. And this is the formula for a trapezoid. So make sure you know those formulas. So take a look at them. And then, of course, you know what this one is. Pythagorean theorem. All right, good luck on your quiz, and then work on your homework when you're finished. I'll see you tomorrow. Bye, everyone.